All right, so follow along with me and help me when you can for number one. We've got the purple stems dominant to green stems in these plants and red fruit dominant to yellow fruit. This is the pirate problem. So green. And then R is and it's telling us we've got two tomato plants heterozygous for both. Well, that of course means this crossed with this. And we do our big old huge Punnett square. Did you even need to do the Punnett square? But you did it anyway, right? So you went big A, big R, big A, little R, little a, big R, little a, little r, and the same down the side. But really, what you need to know is the thing that I emphasized at the end of the notes yesterday, which is that what we're going to get is a 9 to 3 to 3 to 1 ratio. And that ratio is going to be both dominant. That would be purple and red right here. Purple dominant recessive, so this would be purple and yellow. This would be green and red, and this would be green and yellow. What do those numbers add up to? How many boxes are in that Punnett square? How many seeds did they grow? Well, that's convenient, isn't it? 1,600 plants. So we can just say, put 100 on it, on each number from that ratio, can't we? So how many plants for letter A are going to be purple stemmed and red fruited? 900. Did you really need a calculator? No, figured out that you didn't right away, didn't you? Then,
no, I still did.
You still did. Okay. How about, let's see, it said purple stemmed and yellow fruited. 300. And then 300 for green stemmed and red fruited. And then, of course, 100 green and yellow. Easy, right? But then we change things up and you have to rethink. Oh, wait, somebody taught me how I do this thing. And then, it didn't work. I have. You see the lag? It's really slow today. I don't know why. Okay, same stuff, but give the probable phenotypic ratio of a heterozygous for both traits. Well, that's okay. That's the same. R crossed with green stemmed, yellow fruited. What is that? What genotype is green stemmed, yellow fruited?
2 lowercase a's, 2 lowercase r's.
Oh, okay. All right. So big Punnett square. This one's important. This one is going to teach you how to save yourself a butt ton of work. Okay, so pay attention. I make my big Punnett square. I'm all ready to have to write stupid small letters. And I do this one. I know how to do this. It's big A, big R. So because this is how many different ways you could put together an A and an R, right? So there's this, and then there's this, big A, little r, and then there's this, little a, big R, and then the two little ones. Okay, now down the left side, how do I do that? All right, right with the left arm. Same thing? Okay, so little a, little r. Awesome. What's next? You guys, why would I write little a, little r 4 times? It's the same. What can I do?
You can just have one column.
Dude, I can. Sounds like Caleb there, didn't I? Look at,
Now start.
I have 1/4 of the work to do. Those rows would have all been the same, and I would have had to reduce the ratio anyway. Anything that's not heterozygous for both traits, you can do that with. You're going to be chopping off some portion of the Punnett square if the parent is homozygous for anything. This one has to be homozygous for both, so our work is very easy. All we got to do now is fill it in. Everybody understand that? Because that's key to these two trait crosses. What we did in the notes is the biggest, hardest one. Everything besides that, as long as you understand this, is easier, is less work. So what's our ratio here? How many different phenotypes are there? Yeah. Yeah, so we've got one purple stemmed, red fruited, one purple stemmed, yellow fruited, one green stemmed, red fruited, and one green stemmed, yellow fruited. That is a ratio of 1, 1, 1, 1. Good? Yay. Okay. I'm not going to do that. Okay, next. Cattle, the hornless condition. Hieroglyphics. Big H is hornless. Little h is horned. And a bull without horns, that's okay. Let's see. We know that. We don't know that yet. Bull without horns, cow with horns. That's this. Okay. Of the 4 offspring, 1 is horned and 3 are hornless. I was impressed that nobody came up and asked me about this one. Because almost every time when students start to work this one out, and they go, okay, what's here? All right, well, okay, if this was a big H, would any of them be horned? Yeah, they could be, right? But somebody usually goes, all right, well, fine, I get that. But if this is here, it says 3 and 1. That can't be right. It's not 3 to 1. It should be 1 or 2 to 2. There should be 2 of them that are horned and 2 that are hornless of the offspring. What's wrong with that thinking? Chris? Huh? That's okay.
It's just a projection, right? It's just a guess. You don't play now.
Yeah. So if I do fill this in, this doesn't say to us that half of your offspring are going to be horned and half are going to be hornless. That is not what Punnett squares tell us. What they tell us is every time you have babies, there's a 50-50 chance. Every time. Every time you flip a coin, there's a 50-50 chance. Can you flip heads 10 times in a row? Absolutely. It's just not very likely. These two could have 10 offspring and they could all have horns, or they could all not have horns. In this case, it turns out we were lucky. They had one, right? They had one that was horned, and so we know this is a little h. But it's perfectly normal that they had 3 of one kind and 1 of the other. So what was the question? Genotype of the bull and the cow. So bull is this, cow is this. All right, so that's number 3. Number 4, widow's peak is dominant over continuous hairline. Ooh, this is a fun one. Okay. You know what widow's peak is? This thing, right? Yeah. And then little w, none. And then F, big F is short fingers. Little f is long fingers. Okay. And 2 individuals with widow's peak and short fingers. Now let me show you how I would do this. I don't know how you did it. But to me, I feel like once you really understand this stuff, it's almost just like when we said two brown-eyed parents had a blue-eyed kid. You see what I'm saying? So what you can do, if you know they're both dominant, you know they're both going to be WWFF. You know they both show dominance. So there's a capital W here. You don't know his second W. There's a capital F here. You don't know the second one. She's the same, right? She's got a big one. We don't know about the little or big on the second one. And same here. That's them. But look at their kid. A child with continuous hairline and long fingers. What genotype is that kid? Straight up recessive, right? So their kid looks like this. And that came from them. You don't have to do Punnett square. I think you can. It's the big, ugly kind. But where did those little W's and little F's have to come from? Like this, and this, and this, and this, right? That's where they came from. So we know mom and dad are heterozygous. They had to be, or they couldn't have had that kid. And I'll tell you, you'll get through a lot of genetics problems if you just remember, if you see even one trait or two, if they're showing dominant, you should be looking for the recessive kid. The recessive kid tells you they're heterozygous immediately. Got it? Cool. All right, last one. Free earlobes. Dominant to what?
You said free earlobes, and I said where?
Dominant over attached. Oh, just gonna stop working, huh? Oh. Attach. And brown eyes. Dominant to blue eyes. Good. Man with free earlobes and brown eyes. So here's our big E question mark. Big B question mark. Marries a woman with attached earlobes. Okay, weirdo. Attached earlobes and brown eyes. So that's her. Cool. Of 4 children, one has free earlobes and brown eyes, one has free earlobes and blue eyes, one has attached earlobes and brown eyes, and one has attached earlobes and blue eyes. What did I just teach you?
That we have to look at the kid.
And what kid are you looking for, Hazen?
That's a one.
The one that has recessive for both?
Yes.
Did you find that kid? Is the kid there?
Yes. No.
What kid are we looking for? What should the kid look like if they're recessive for both?
Oh,
Attached earlobes, blue eyes? Is he there?
Yep.
Yeah, he is. That means there's a kid that looks like this. What's that tell you? Well, we knew one of the E's was going to be little from her. Where'd the other one come from? So that and that and that. This is the same problem essentially, except that she's homozygous for one. So this is not hard once you get the hang of what to look for. Okay? Are we all good?
no. Don't do it. Don't do it, Mr. Sandro.
Here's what you get to do. Number 1, you get to take that Google form again if you didn't get a perfect score and get a perfect score. Number 2, you get to do the backside. On paper. Couple of them are slightly hard. Still just 2 traits though. You got this. Actually, one of them's just a 1 trait. All right, good, Brady.
You said yesterday that we have to show points first for every school. Remember? That's the thing.
Let me see if there's any I don't care. You don't have to do a Punnett square for. I'm gonna leave it up to you. Your choice. We'll see how it goes. When I work through them, we'll see if you should have done a Punnett square or not. So those are due tomorrow. Your test, which will involve problems like these, is Friday. It's not a long test. It's mostly genetics problems with a few questions thrown in there. So this is sort of the best way to prepare for that. So please work on these for the remainder of our time.